This is the skeleton of a diatom. It's a microscopic plant, an alga. It lives in lakes, in pond scum, and the skeleton is a beautiful, intricate, lacy structure, and the beauty of it is that it fossilizes. If you look in ponds widespread over the United States, you'll find a diatom called Stephanodiscus niagarae. It's very, very common. But if you look in Yellowstone Lake, you find a unique species which is only found there, Stephanodiscus yellowstonensis. If you take a core sample from the mud below the lake, underneath the lake, you find Stephanodiscus niagarae at 14,000 years old. 14,000 years ago, the climate was cold and wet, and the diatoms were just the same as the diatoms in the rest of the country. But as you look in more and more recent core samples, 12,000 years, 10,000 years, you get a gradual change from Stephanodiscus niagarae, gradually changes through all these transitional forms. At about this point, it becomes recognizable 10,000 years ago, it becomes recognizable as yellowstonensis, and goes on to today, where it is yellowstonensis. These are definitely two different species. The differences between them are quite subtle. You have to find out by counting ribs and spines. And if you do that, as you go along this timeline, you see the change gradually occurring. This is a perfect example of intermediates in the fossil record showing the complete history of the evolution of a new species.